All right, so the last video gave you started to explain how to use how to do stoichiometry problems for chemical reactions, and we did a problem at the end there. And the key thing here is to set up, at least the way that I do it. Other teachers would do it a different way. Is first of all set up what I call a recipe table, and that's going to give you a relationship between how many moles and you're going to need in a chemical reaction in relation to the chemical equation, and that's going to be your central piece to working these stoichiometry problems. So what this video is going to do is it's going to go over the steps that I would suggest using in doing the stoichiometry problems. There will be, I believe, five more short PowerPoints on different types of problems, and I will post those, and I'll post also the no voice. But this first one is going to show you how basically the steps on how I would do them, and pay attention to them, because this is it for the stoichiometry. We got one more topic to do basically with big chemistry, and that's we're going to be talking about thermal chemistry. That'll be hopefully we'll start that next week, and then after that we get into the atomic world. So it's going to be kind of intense here, because there's going to be a lot of moving parts, and you're going to have to be able to move those parts to where you want to use them. Okay, so what I have is I have broken these stoichiometry problems into basically 6 steps, and you won't be using all 6 of these steps all the time, but these are good. So the first thing you're going to do is make sure you have the balance equation with the states, okay? Because that's important, because that's going to decide how you're going to find your moles. Okay, next you're going to do is set up a recipe table, and that's to show you the relationship between moles and the chemical equation. Okay, and then once you have that, you're going to, from the state of your substances, you're going to find the number of moles. Okay, and that's going to depend on if it's a solid, you'll be using molar mass. Solids, molar mass. If it's a liquid, you're going to be using density and molar mass. If it's a gas, you're going to use PV equals nRT, the ideal gas law. And if it's aqueous, you're going to be using molarity. Okay. All right. All right. So once you find moles, there'll be times when we will be we're going to have to find a limiting reactant, and there was a short PowerPoint about that and how to do that. So if you have more than one reactant, you have to figure out which one you're going to run out of first, and that's material is going to be what's going to determine how much product you made. And we'll go again. We'll have most of these problems actually will be having a limiting reactant. Okay, after you determine the limiting reactant, now you can actually figure out how many moles of product are going to be formed, okay, or whatever's being asked for. And then what you got to do, once you get moles, you're going to have to come back and find out how much of the product in its particular state you're going to get or need. All right, so those are the steps. So let's go. This first problem is going to be going over how to do it, and then there'll be subsequently other short. Okay, so this one has to do with the combustion of octane. So the first thing is balance equation in all the states. Okay, so you have to be given the state. So this would have been a word equation. Liquid octane combines with oxygen gas, produces carbon dioxide gas and liquid water. Okay. All right, and then set up the recipe table. Okay, so here's your moles per recipe, and then what you're going to do is, given in recipes, you can figure out moles, or so if you're given like five recipes, you can figure out how many moles you're gonna need, and that would be 10. Okay, or let's say you have, you know how many moles, so let's say you have 180 moles, and you want to figure out recipes, you can divide that by 18 and come out with 10. Okay, so this is our setup point. Okay, and would be, this is what you need to do your problems. All right, because what you're going to do is you're going to start out with grams, milliliters, etc., and using its state, you're going to figure out how many moles, okay, and then how many recipes, and then you're going to come out and figure again how much the material you need or get. Right. So step 3, you're going to, depending on the state of each substance you are given, you'll need to find number of moles. Again, if it's a solid, you'll be using molar mass. Okay. So if you're going from grams to moles, you'll be dividing by the molar mass. If you're going the other way, you'll be multiplying. If you go from moles to mass, you'll be multiplying by molar mass. All right. So if it's a liquid, it'll be usually in milliliters. Okay. First thing you have to do is find density. All right, and then once you find density, you'll use molar mass. Okay, or the other way around. You figure out mass. You start with mass. You figure out. Going from moles, you go from moles to mass to density, or the other way around. Okay, so and you'll see how this works, and then solutions. If you're given a solution, you have to know the molarity, and from molarity you can figure out the moles or the milliliters. We went over that in previous videos. Okay, and you'll see how there'll be examples how to do that. Right, and gases. So we usually measure the volume. It'll be a volume measurement, and it'll usually be liters. We use the ideal gas law, and then you can solve for N. If you're going to use recipe table, going into recipe table, and if you're going out of the recipe table, you can solve for V. What you have to know for this is you have to be given pressure and you have to be given temperature, and those have to be constant. And of course, the the universal gas constant, which for these units is 0.0821 liters atmospheres per mole Kelvin. Okay, so let's go back to the equation we just had up, the combustion of oxygen. So let's say we have 150 mils of octane, and we react it with 5 liters of oxygen at pressure 1 atmosphere, 300 K. All right, so first thing we have to do is we have to figure out how many moles of, here's your equation, but it's not in moles, it's mils and liters, so you have to figure out the moles. So this is the liquid, so you're going to be using density and molar mass. Okay, and this is gas, so you're going to use PV equals nRT. All right, so we have 150 mils of liquid, so you have to be given the density. Here's the density, and the molar mass is 114 grams. Okay, so first of all, figure out how many grams it is, so you can use the density. So 150 mils times 0.7 grams per mil. I'm using here dimensional analysis. The mils cancel out, and you end up with 105 grams of octane. How many moles? Well, divide by the molar mass, and you get 0.21. 921. Right, now how many moles of oxygen? Okay, there's 5 liters. So, using the ideal gas law, you have pressure is 1 atmosphere, volume is 5 liters. I'm leaving the units off here because if I have to write units, it'll all work out. And there's the universal gas law and 300 K. And I do the math and I come up with 0.20 moles of oxygen. Okay. All right, so that's so now I have moles, and now I can put those numbers into my recipe table. Okay, next thing, since you're given more than one reactant, you have to find out if which one is limiting. Okay, now they might be exactly used up, but usually one is going to be used up before the other. So the way to do that is you find out how many recipes each substance will get. So if you're given 0.921 moles, and for every recipe you need 2, you divide that by 2, and you'll get 0.461. So that means you can do this reaction 0.461 times with this many moles of octane. Okay, so now just kind of ignore this. Don't worry about it. Then go over here and figure out how many recipes you can get with this. Okay, so you divide the 0.2 by 25, and then you come up with 0.0008 recipes. Okay, so the oxygen, you can do only do the reaction 0.008 times with 0.2, and with the octane you can do it this many times. So you're going to run out of the oxygen before you run out of the octane. Okay, so you can only do the reaction 0.008 times. Okay, so the oxygen is the limiting reactant, and that's going to determine how much product you make. Okay, make sure that when you do these independent. You see how many times you can do the reaction with this guy, how many times you can do it with this guy, compare them, and the guy that gives you the least amount of reactions will be your limiting, which is this, the oxygen. Okay. All right, so here you go. So this is now including, so you can do the reaction. I like to put times. It's just because it's not really just a number. It tells you how many times you can do it. So this number here, from the oxygen, it determines how much product. Okay, now what we need to do is figure out how many moles of your product you're going to form. Okay. All right. Well, so he's going from recipes of moles. Every time you do it, you need 16 moles. You're going to do it 0.008 times, so that's going to give you 0.128 moles of carbon dioxide. And then same thing with the water. You can do it 18. This number here, okay. Every time you do it, you need 18 moles. You have 0.008, so you can only you can get that many moles. All right, so you're all set. So these are how many moles of each of your product you can get. But the thing is that what we want to determine is this is a gas and this is a liquid. So we want to find out how many liters of gas this will form and how many milliliters of liquid this will form. And so we got to use our relationship between for our particular states. Okay, so the carbon dioxide is gas and water is a liquid, so we're going to use PV equals nRT for the gas. Okay, so use the ideal gas law and solve for V and plug everything in. And so V equals, so we have V equals nRT over P. So N is 0.128, R is this, 300 Kelvin divided by 1 atmosphere, and that's how many liters of carbon dioxide you're going to form. Okay, for water, you have to know the density, 1 gram per mil, and the molar mass is 18 grams. So first thing you got to do is find out how many grams is 0.144 moles of water. So you multiply by the molar mass, all right, which is 2.59. And then you use the density to figure out the mils of water. And there's different ways you can do that. I like setting up ratios for density. So it'd be uh, x milliliters over 2.5 gram, 59 grams. You don't have to do it this way. You can use dimensional analysis. Over 1 gram, 1 mil per 1 gram. Okay, and then then solve for x. Okay, all right, and that's what you get. See, your answer is gonna give for the amounts reactant we're given. We went over 2.5 mils of water, 5.9, and 3.15 liters of carbon dioxide. Okay, and so this is the first one to show how to do it, and this was there will be problems that look like this in your worksheet. The next, so I have 7 more that I'm going to go over, and they're very short little PowerPoints. And okay, so these guys will be the ones that will be the worksheets will be set up. The problems on the worksheet will have problems done that are almost exactly like I'm giving you here. You can use these notes for the worksheet and the test. I just want you to be able to learn how to, where to start looking out and how to figure these out. Okay, so that's all. We'll go on to the next one.